Good evening to everyone. In today's class, we will discuss about the block diagram representation of an op-amp. As mentioned earlier, nowadays op-amps are available in an integrated circuit form, that is in the IC form. Commercial IC op-amps usually consist of 4 cascaded blocks. The block diagram of IC op-amp is shown in the figure. It consists of 4 blocks. First one is input stage, second one is intermediate stage, third one buffer and level shifter stage, and fourth one is the output stage. So first one is input stage. So the input stage requires high input impedance to avoid the loading on the sources. It requires 2 input terminals. It also requires low output impedance. All such requirements are achieved by using the dual input balanced output differential amplifier as the input stage. The function of a differential amplifier is to amplify the difference between the two input signals. The differential amplifier has high input impedance, and this stage provides most of the voltage gain of the amplifier. And second stage is the intermediate stage. The output of the input stage drives the next stage, which is an intermediate stage. This is another differential amplifier with dual input unbalanced output configuration. That is, in this case we are applying 2 inputs and we are taking the output at only one collector with respect to ground. So the overall gain requirement of the op-amp is very high. The input stage alone cannot provide such a high gain. So the main function of the intermediate stage is to provide an additional voltage gain required. Practically, the intermediate stage is not a single amplifier but the chain of cascaded amplifiers called multi-stage amplifier. And third one is buffer and level shifter stage. And before going to know about the level shifter stage, here all the stages are directly coupled to each other. As the op-amp amplifies DC signals also, the coupling capacitors are not used to cascade the stages. Hence, the DC voltage level of previous stage gets applied as the input to the next stage. Hence, stage by stage DC level increases well above ground potential. Such a high DC voltage level may drive the transistors into saturation. This further may cause distortion in the output due to clipping. This may limit the maximum AC output voltage swing without any distortion. Hence, before the output stage, it is necessary to bring such a high DC voltage level to 0 volts with respect to ground. So, the level shifter stage brings the DC level down to ground potential when no signal is applied at the input terminals. Then the signal is given to the last stage, which is the output stage. So final block is the output stage. And here the output stage should provide low output impedance, large AC output voltage swing, and high current sourcing and sinking capability. The push-pull complementary amplifier meets all these requirements and hence used as an output stage. This stage increases an output voltage swing and keeps the voltage swing symmetrical with respect to ground. The stage raises the current supplying capability of the op-amp. So this is about the block diagram of an op-amp. So thank you.